Hello and welcome to the Connectology podcast. Here, Road Night Taylor's influential team of elite connection specialists and their expert guests help you to better understand distribution and transmission network connections and how to acquire them faster, for less cost and at lower risk.
Hello, I'm Pete Aston, and welcome to another episode of the Connectology podcast from Road Night Taylor. Now, I'm joined today by my colleague Philip Bale, who's often on our podcast, but more importantly, we're joined by Dan Nicholls from SNRG. Welcome, Dan.
Morning.
Nice to have you. So, Dan, do you want to just give us a little bit of a brief intro to who you are, who you work for, what you do?
Yeah, so I'm Dan Nicholls. I am the Chief Product Officer and Commercial Officer at a company called SNRG. And SNRG is essentially a microgrids business. So we work with the new build residential sector. We also work with new build industrial and commercial sectors, and indeed some existing operators in the non-domestic space. And we fund, develop and operate what we call microgrids.
Okay. So how long have you been doing that? Has SNRG been going a long time? Have you been with them a long time?
So we're about 6 years old.
Okay.
Founded in around 2018. And really the hypothesis of the business was we need to electrify to decarbonize. But obviously if we do that, we're going to deal with a number of challenges. And I'll talk a bit about the challenges in a moment. But SNRG's idea was that can we come up with a solution that we can fund and run that helps us solve some of these problems and gives us a solution that allows the built environment to decarbonize in a way that doesn't cost any more for developers and indeed for our built businesses and residents.
Okay, that's interesting. Because I think with Philip and I, we're tending to work with the bigger end of the spectrum with large-scale energy developments. So we were having a chat just before the podcast started. So there's some really interesting stuff going on in the microgrids space. So do you want to just start at the beginning of the story with the problem that everyone's seeing around decarbonisation and talk us through from there?
In terms of my background, I actually started out in land use planning, working in the public sector. And one of the things that I got interested in really early was how do we have the built environment to decarbonise? And originally that perspective was what are the planning policies that can encourage development to decarbonise? And the kind of hypothesis is that surely if we're going to decarbonise the built environment, the new build segment is the easy win. Surely we can achieve that. And what I've learned over the course of my career is actually it's really complicated. It's actually more difficult than you realise. It's not just a question of putting a planning policy together and saying we should have solar panels on the roof of all new houses. So the key thing here is to decarbonise, the majority of new homes will have to be electrically heated. And of course, we need to move away from the internal combustion engine. So the likelihood is we're going to have electric vehicles and electric vehicle charging as part of our new built environment. And that creates a number of challenges for the industry as a whole, for the construction industry as a whole. If you, traditionally, the way that the large housing estates are put together is that what we call a master developer will typically pull together the site, get planning permission, and look at servicing the site with infrastructure. And that is traditionally gas, water, electric, and other infrastructures like telecoms and so on. But those are the key utility infrastructures that are required. The model over the last 20 years has really built up around the idea that you go to an independent contractor who will put that infrastructure in. That independent contractor will either work with the DNO or on the gas distributor, or they'll go to an independent. If they go to an independent, they will get what they call an asset value, an offset payment against those costs.
So when you say independent, you don't mean an IDNO type model?
Exactly, yeah. So, and the key thing about the IDNO compared to the DNO is the IDNO is able, under its license conditions, to dip into its future revenues to offer a payment to help to reduce those infrastructure costs. So that model is starting to mature. However, if we move away from gas, which is something that is happening, we're seeing the government's intention to introduce new building regulations probably next year to prevent new natural gas connections in the new build housing segment. So effectively, moving away from gas means you have less infrastructure on the gas side, but you lose asset value contribution. And you load that demand into the electrical connection. And what that then does is it creates an increased demand for your electrical infrastructure. And we know that's causing problems for the DNOs to connect.
So the sort of average demand of each property is gradually going up with adding in the electric vehicles, the heat pumps and that sort of thing.
Exactly. So traditionally, you would typically not have to worry about heating as a heating load when you calculate the demand on the electricity network. And of course, we're looking at electric vehicles, which is a large load per home. But of course, not everybody's charging at the same time. So it's a challenging equation to work out how much that capacity is. But we know it's a lot more, and we know that's a problem for DNOs. So what that means for the infrastructure developer is they've got less asset value and they've got more cost.
I think just going back, obviously, one of the challenges of the DNO is they also have these potential larger demands for much longer periods of time. So the way the traditional homes have been built up is after diversity maximum demands, but it tends to be quite short. The longest thing that would be on would be your electric oven, but then you have a 7 kilowatt, 11, 22 kilowatt EV charger that's on for longer durations of times. It makes it much more difficult for them to have that diversity, and that could happen with neighbours, which then means beefing up the infrastructure for that if they're assuming everyone's operating like a little island.
It's difficult to forecast as well, which is the other thing. Electric vehicles are still in its early stages, so we don't know whether everyone is going to charge electric vehicles from home in the future. We certainly think more will. And of course, with heat pumps, the beauty about heat pumps is they are efficient. They will, they tend to work on a sort of efficiency ratio of 2 to 3 to 1. So if you effectively 1 unit of power can give you 2 or 3 units of heat, which is great, but under either a post-fault condition when you're restarting every system, or when it's very cold, the heat pumps don't work quite as efficiently. So the network sizing has to think about this issue too, as well as hot water and as well as electric vehicle charging. So what that means for the house builder and for the infrastructure developer is the bigger demand on the DNO network. Now, we know that regulations are evolving to try and rearrange where those costs sit, but today we're seeing very much more expensive connection costs and long lead times to connect new housing developments. That's a serious challenge for the infrastructure developer.
And the long lead times are coming, you're seeing from the grid side to actually reinforce the network or whatever to actually provide those connections.
Yes, that's right. And you're also seeing things like interactivity, so multiple sites being managed by the DNO. Actually,
that's a painful process.
Indeed. I think it's something we could do better through collaboration, generally speaking, but it's all these problems are fairly new for the infrastructure developer.
If we take a step back a second, because myself and Pete, we've both done times in innovation teams, and there's obviously a lot of people will have heard of the term microgrid, may understand it to a certain instance, but it's probably worth just describing a little bit around how the existing network works and how a microgrid works and the key difference between them. So if I do the traditional network, and then I'll hand over to you as the expert to do the microgrid of how it differs. Say a home gets connected, each individual home has their own meter, their own supply that's coming through, and they have the meter as a boundary between their home and the IDNO or the DNO. If they have electric vehicle chargers, solar PVs, batteries, they could choose to do those. But often what a lot of residents look at is when they look at those of putting the solar PV on the roof, the batteries, the payback, the return on investment can be quite long, because at the moment, under the current market mechanisms, there are benefits, but they're quite expensive to start with, quite a big capital outlay, and often the people that are doing it aren't doing it because it's going to make them serious money. It doesn't have a particularly quick payback. They're doing it because they want to have a positive impact on the environment, the society themselves, and they size the solar panels, the batteries, their car, and try and manage their own home load actively at a home level. And you could have a whole housing estate doing that on an individual basis, whereas a microgrid is different because...
So, indeed, so in your scenario, you've got, say, let's put solar panels on the roof, battery in under the stairs, electric vehicle, and so on. And of course, the ideal scenario would be all of those things work together and they minimize the demand for energy for that home, which equates to cost as well as efficiency. But it's efficiency back to the DNO as well, of course, because if you're not drawing power from the network, then you're reducing the requirements on the network. So that's the ideal scenario. In this traditional scenario, that's very hard to achieve. Typically, solar panels on an all-electric home might use 40, maybe 50% of the power produced by the solar panels in the home. The rest of that then would be exported to the grid. You might get a small payment from a supplier to do that, but the ability to really capture the value of that within them is really difficult.
Just for context, that's like about 10% typically of what you're actually buying the power is what they'll sell it back or buy it back off you. So if you're buying it for it, it's in the 20s of pence. And if you're selling it to them, it's 1.5 pence, something along those lines. Is that right?
Yes, that's about right. And indeed, if you think about the volumes of energy, a typical solar array might meet maybe 8-10% of the annual demand of the home in a modern electric home. So it's not really that efficient in terms of using renewables. And if we assume that decarbonising is something that we want to do. So with a microgrid, you take that meter you talked about and you take it out from the home and you put it at the edge of the community. So let's say we have 200 homes in a housing estate. The meter that interfaces with the wider energy system sits at the boundary of the community. And then every home, every PV array, all the electric vehicles and so on, all sit behind that meter. Why that's good is because all of those solar arrays then can operate as one, working together. They can be combined with a single communal battery solution. And this is what Synergy does. Rather than put batteries in the houses, we put one battery in the community. That's more cost effective from an infrastructure point of view, and it's more efficient from an energy management point of view, because then you can move to a point where perhaps you're consuming 40% of your solar in the house. So maybe where you're consuming 80, 90, 100%, because one of the reasons why you don't consume solar in a traditional scenario is people go out. They maybe go out and work in the daytime when the solar is available. In a microgrid, that power can go to the neighbour, or it can go to the battery, for example. And indeed, you can manage things like electric vehicles to make use of that solar power. So it's a much more efficient energy solution.
So in the best case scenario, with that microgrid, none of that solar power goes out from the meter into the DNO side of things. It's all kept in that small microgrid.
Exactly that. And we typically size our systems so there's a bit of excess solar at the outset. But we do that knowing that as we optimize, increase the efficiency of the microgrid over time, as we learn about people's behavior and so on, we can really target that 100% use of the solar on the site. And I think that's a really important principle of decarbonisation. Yeah. Let's generate it locally and let's use it locally.
So obviously at that point, you're optimizing rather than as a household, you're optimizing as a community. So when someone's out, you're using their power and vice versa when they come back. And then you have that diversity across a portfolio of properties. Some people have EVs, some people don't. So you're making best use of the energy when it's available. And I'm presuming also if you have a battery, you have one party, one entity, your company or others for doing microgrid operation, because there are competitors who can then take the intelligent choices of when to charge that battery, when to discharge the battery. So you've got someone that's looking at it at a much bigger level rather than a householder trying to decide when they optimize their own individual battery.
So now I'm interested. Who's doing the optimization? Have you got someone in a little box, sort of ramping everything up and down, or have you got some snazzy controller? I'm assuming
we do. I mean, it's obviously part of our platform solution. I would be lying if I said there wasn't ever anybody in the little box working out how the solution might work and how it can improve it. That's also, it's we always say these are highly automated, but they're a mixture of both.
Sure.
So yes, the system itself is programmed to follow the constraints on the site and the price signals that work in the site to efficiently optimize the use of renewables. But of course, we have a team as well that look at the site and say, okay, could we do it better? How do we work differently? What are the market signals that we could work to make this all work better for everybody?
So I guess from that point of view, each house premises within that microgrid is then connected into that controller. So you know what the consumption of the house is, you know what the output of the solar, if there is some solar on the roof, that sort of thing. So is that infrastructure that you have to put in as part of the microgrid from day one then?
Yes. So the key thing about a microgrid system is you need to put in communications alongside the energy assets, and you need a control system. And that has some site components and it has some cloud-based components. And they work together to gather the data about energy consumption. So we monitor the meters, so we know what each house is consuming, for example. We can also meter the electric vehicles, and we obviously meter the battery solution as well. And the data that we ingest then drives the run strategy that we use to optimize the assets. And of course, we look ahead, we look at weather as well, and we look at how we can run that system better tomorrow as well.
Okay.
And obviously we're talking at the moment about residential, but it's not just limited to residential. It can also be industrial, commercial, bigger industrial commercial estates. And it's not limited just to one sector, is it?
Exactly. The technology applies to both. The key thing for the residential sector is, and I'll talk about it a bit more in a moment, microgrids can benefit developers, infrastructure developers and house builders, that's important because we're going to decarbonise. We shouldn't just leave the burden of that upon the house builder. It also can support the residents, but it also needs to make sure that the service that we offer to residents allows residents to carry on with their lives. It's not disruptive. Ultimately, I'm a big advocate of the energy transition and really interested in that, have been for some time. But when I go home, I just want to live my life. So that's an important part of the offering for residential sector. However, in industrial and commercial segments, there's lots of applications for microgrids that vary from, again, helping to decarbonise in a light touch way, but also working very closely with operators to tackle the big problems that face the transition away from high carbon processes toward electric processes.
And I guess that an industrial commercial customers may be a bit more flexible with what they can do with their demand. Like, say, residents, you want to go home and not think about your electricity, whereas a industrial commercial customer can maybe have some of their own systems in place to ramp their own loads up and down if they need to help with whatever microgrid controller is doing.
Yes, so we design, we fund, we operate. That's our solution. We can offer the microgrid as a service to a client. But when it comes to working with operators of industrial sites, and one segment that's emerging we're all aware of these days is data centers. So working with segments such as that, we can work alongside those segments to capture the requirements and ensure that the microgrid can service those requirements. And we know that, for example, a data center's power demand is enormous. The growth in the segment is also huge. But importantly, we need to make sure the system can provide the resilience to ensure that the key service that's been offered is not interrupted.
So I think Pete mentioned that it's something that Road Night Taylor doesn't do day in, day out because it's fairly niche, it's fairly new market that's coming through. One of the things that we do far more of is the private wire connections. Effectively, someone saying, I'm going to develop a big solar farm, I'm going to plug it into this big industrial commercial building. One of the challenges that we will often see is the solar developer community want to try and develop something as big as possible. They then have to try and work out how long will that specific building need that power for? What happens if it goes? How much will they utilize of that? How could that change in the future? How much of it will be spilled back into the network, which then ends up having a different rate to the person that's consuming it? I'm presuming on a much bigger industrial commercial scale, you can then have that one big plant. Whereas if we were looking at as a project of doing 10 industrial commercial buildings, you wanted to put solar into each of the buildings, you're talking 10 separate either roof mounted or ground mounted arrays being physically plugged via separate wires going into the individual properties.
Yes, and I think the microgrid applies the same principles that we use in the residential space. It doesn't make sense to put solar on every building if you've got excess generation as a result of that. So a microgrid can then allow you to put the solar or wind potentially as well and storage and so on in the best location and ensure that it can get socialized to the users of that energy. So that's a kind of key principle. It doesn't mean we don't have to do all that design thinking that you just talked about. Yep. Modeling, forecasting, etc. That's all part of the service that we do.
How do you find the interaction with the DNOs with this then? So obviously we deal with DNOs day in, day out, and some are easier than others and there's different challenges, but obviously microgrids are a fairly new sort of concept. So how are you finding that interaction with the DNOs on this? Are they getting it?
So obviously each DNO is slightly different. I think I would definitely say that DNOs understand the concept of microgrids. And ultimately we're talking about a bulk supply from a DNO's perspective. And they need with generation connected behind that meter and flexible load. So from the DNO's perspective, it's ensuring that they can connect those assets to their network. But what's different is the microgrid has a control system. And we talk a bit about the kind of connection rules that are emerging in the DNO and the IDNO space. But one of them is the G100 guidance that is evolving and has recently evolved to incorporate flexible demand as well as generation. So our microgrid solution has a G100 compliant load control system that allows us to manage the flexible loads on the site as well as the generation. It's a new area of guidance and regulation, but it's something that we're already starting to talk to the DNOs about using and trying to make sure that technology can be used to encourage the DNOs to be more flexible with their connection requirements.
So I think there again, go back to the residential scenario, there's two different elements of where you get that flexibility. You can get the flexibility from the automated processes, which is your batteries, your heat pumps, your electric vehicle charging, but also we're having a conversation earlier around the residents can actively try and do things to, as a cooperative, as a group, to try and basically manage their own energy needs so that they are making active choices together, which ultimately benefits everyone in the system.
And just to take that back to the DNO point, I think there's a tendency, because the DNO is the incumbent, for us as kind of industry actors to be critical of the changes the DNO is working through and the pace and so on. I think to a point that's slightly unfair. And before I joined Synergy, I worked for Centrica on an innovation program, which was called the Cornwall Local Energy Market Program. And the real centre of that program was to build a technology that could allow flexibility to interact with the DNO and indeed the electricity system operator as well, so that the ESO. And we know that the DNOs are trying to introduce the use of flexibility as a way of managing constraint and congestion on the grid. The microgrid offers that tool. So rather than have, let's say, 200 or 500 or 1,000 homes connected to a DNO network, that's a challenge for the DSO, the distribution system operator, to try and unlock the use of flexibility. If that was a microgrid, all of that service can be curated and offered to the DSO as a service to help manage constraint.
And with the fact that you've got technology there as well as just people changing their habits, you've got the battery that can also back up the changing of habits as well, which then potentially gives you the double whammy of having that control system set up with one, and obviously presumably cheaper from the fact that you've got one contract going to one party as opposed to 200.
Exactly. The multiple levers, the single point of interface. But I think the other key thing to note is that actor, the microgrid operator, Synergy, is looking after the residents as well. So this has got to be about residents benefiting without residents taking additional risk and indeed being able to get on with their own lives. I think the microgrid offers that ability to create that curated interface between residents and the markets.
And I guess from a DNO point of view as well, if you've got 1,000 houses all with solar on it, you've got no control over that. You're just relying on some diversity type principles to work out how much is coming out from there. If you've got microgrid, you're going to have a set export capacity that you are allowed out of that, and you're controlling that within your system. And so from a DNO point of view, they get that benefit that they don't have to think about what's the diversity of this group of 1,000 houses. They know what it is because it's whatever you've agreed the export capacity to be at that interface point. So there is definitely a benefit to the DNO.
And indeed, beyond that set of operating parameters, the DNO can also reach into the microgrid to say, look, we've got an exceptional circumstances coming. Could you turn down the solar inverters? In theory, technically, that could be done, and that could be offered back as a service. Of course, the key thing is that's got to be to the benefit of the residents.
Yeah.
So we still need a market mechanism to come to compensate residents for providing that service.
And it's probably also fair to say that this is still a new concept, is probably a sort of a harsh term to do, but it's still a very new market. At the moment, microgrids are relatively small, a very, very small proportion of new houses will go in with this. But the fact that this is now something that's being done is because you must believe this is a commercially viable option of going through, which benefits the residents because they have to want to do it, but also benefits corporate entities who want to invest and put the infrastructure in to actually make this work.
Yes, absolutely. We do think that. We know that microgrids in the residential space is new, but microgrids have been around for a while in other segments. Synergy is backed by private equity firm called Aston Infrastructure Partners and Centrica, the owner of British Gas in the UK. So we also know that others believe that this is a model that is worked and solves problems in the marketplace. And we're not the only ones. That's the other thing to mention. There are other microgrid operators in the domestic space as well as the non-domestic space that are also bringing forward models that can help solve the challenges for developers as well as for residents.
Yeah, I think that sort of competition is good in the sense that it breeds confidence in the market and common learning across different people and platforms.
Hi, I hope you're really enjoying this episode so far and are gaining a lot of very useful insight. If you're a new listener, I hope that you'll feel like you might come back. If so, make sure you hit the follow button and feel free to sign up to our newsletter, The Connectologist, at roadnighttaylor.co.uk so you don't miss out on any of the podcasts, webinars, case studies, thought pieces and explainers.
From a more of a techie commercial point of view, I think you were telling me earlier that these microgrids are effectively classed as a private license exempt network. Is that right? And is that how you're running them?
Yes. So to move that boundary meter from the house to the edge of the community, you then technically the network becomes a private network because it's beyond that final consumption meter point. The model is based on the Energy Act, which still regulates all of the activities in the energy market. But within the Energy Act, there was a set of exemptions from the need to have a license, effectively. And private networks fall within that. So they are regulated by the Energy Act, but you essentially don't have to have the same set of sign-ups to the license conditions that the DNOs or indeed license suppliers have. And the key thing to say is that obviously that doesn't exclude private networks and microgrids from the need to protect consumers. So consumer rules still apply. If you're a resident sitting on a private network, you still have some rights around choosing your energy supplier.
Yep.
And there's a requirement on private network operators to facilitate that. So it uses a license exemption. It necessarily needs to the way the energy system's been constructed and regulated, but we build our networks to the same standards as the license conditions. We work to the same standards on suppliers, and consumer protection still applies.
Yeah.
So it's a quick question. Why would a house developer not do this? Why are you not in every single new housing developer that's going through? Why is this not an option that they're doing?
I mean, we think that housing developers should do this, and we'd be keen to work with as many housing developers as we can. I mean, I started to talk at the beginning about the move away from gas and the burden of moving to all electric and challenges around the costs of the grid. The other thing to bear in mind is that when that places a burden on residents. So all electric homes are good because we're not using gas. So in theory, that's a good step towards decarbonisation. We know that creates a problem for the DNO. We know that increases costs for developers, but we don't really talk about how that increases costs for residents as well. All electric homes cost more to run than gas homes. Even obviously we're increasing the efficiency of those homes, but fundamentally electricity is more expensive than gas. So that's a key part of this equation. We need to then think about how we do that. Is about installing renewables. And that's something that we see that's coming. And so from our point of view, if we're going to solve this problem, we're going to deliver sustainable homes, and particularly if we're going to do it in areas where we've got large growth, we know the government is keen to push for that. We know local planning authorities want sustainable communities. We need to think about the renewable energy strategy. And the key thing that Synergy could bring is funding for that renewables, so that it allows developers to deliver sustainable homes that are also low cost for residents without the additional cost of doing so.
Yes. So just to follow on from that, in your perspective, if a home was to have its own solar panels, its own heat pumps, electric vehicle charging, compared to a conventional gas heated property, it becomes more expensive from an operational perspective. And where you're looking at it is basically giving the ability of having the rooftop solars on the most appropriate homes, sizing it to the community rather than the individual home, making better use of that, and potentially then also putting solar PV on communal spaces where there'd be no incentive for a house builder to do that at the moment, potentially even some ground-mounted solar that would feed into the community. At that level, can it then become more cost-effective than a traditional gas-connected estate, gas-heated estate?
It can become, at least as a comparison. So okay. I think that's the key thing. You've got to deal with the fact that electricity is 3+ times more expensive than gas as a starting point.
Yep.
If you've got heat pumps, yes, of course, that helps with that. But of course, the fundamental principle here is that if you're going to have electrical home, electric transport, then it's going to cost more than gas. So what you can do with microgrids is you can bring those sort of cost into a more comparative point of view, and you can create the mechanism to allow future savings. And this is the key thing for me, is that as the markets transition, as renewables get cheaper, as the market becomes more dynamic, the microgrid can bring those savings forward so that residents can ultimately end up with much lower cost operating conditions as well.
Yeah. So I think we're all in agreement that if we want to hit requirements of decarbonising, transport and heat are the two big ones. Heating is probably more controversial than transport, I think, at the moment in terms of coming through, and obviously anything that we can do to try and make it a logical choice that people want to do it. And one of them is price. Finance always comes into it, capital costs, ongoing costs, but also to take out the headache of how to do things and the shock value.
Yeah, I think we sometimes overlook the complexity of living and operating in a smart all-electric home with say a heat pump, hot water tank, with an EV charger. You've then got to think about who maintains those assets. How do they work together? As a resident, do you have multiple apps to try and control those systems? Do you have multiple suppliers? If you're trying to get involved in, we talk about the flexibility emerging within the energy market, the role of aggregators in unlocking that. If that is going to emerge and introduce smaller chunks of flexibility, residents have to engage with aggregators as well as suppliers. So yeah, it could be really complicated to live in a smart whole electric home. And again, one of the key underlying principles of the product we've developed as a microgrid is to make that simple.
And I was going to pick up on that. What's the experience of residents who are currently connected on these microgrids you're running? Is it, have they generally given some positive feedback, or do they just not know that you're there?
Yes, ultimately, not having any feedback is potentially also a good sign for us. And we've consciously designed our user experience to look and feel as if it was any home anywhere in the country. So having no feedback can be considered as a good thing. However, there's always a nervousness when people aren't talking to you that what do they really think? And we've been really lucky in that some of our early adopters of our solution. And again, these residents aren't deliberate adopters of microgrids. Increasingly they may be, but really they're just people buying houses and living their lives. And we've had some really positive interactions, lots of dialogue. A number of our residents are interested in seeing what more can the microgrid do, what can they get out of it, what can they learn about it. So we're benefiting from having some really interested early adopters. But importantly, we always want to hear about feedback, particularly if people aren't happy. But sometimes no feedback is also a good thing, because then I think people are getting on with their lives.
So I think I'm keen to now talk about where this is going. So you say you've got a few microgrids up and running already. We've talked about the benefits of it. Look like a great thing. So where do you see the future of this going over the next sort of 5 years or so?
In industrial space, as we're moving away from fossil fuel driven kind of heating and processes, we think there's great opportunities to integrate flexible generation, storage, load control. So microgrids has a big role to play, I think, in managing that space, particularly given the challenges of upgrading the distribution and transmission infrastructure at the same pace. So I think we've got a big opportunity there for this type of product and technology. But perhaps the bit that excites me most is the ability to move into creating new communities, maybe even new towns, using these energy systems, create microgrids at the scale of hundreds or thousands of homes as we build out the new growth agenda that the government is promoting. Then I think we can deliver genuine net zero new communities. And importantly, we can do that in a way that doesn't place a burden on developers, but also creates the opportunity for residents to be more involved in that process and create a different model. So for me, it's really about potentially building new net zero towns and new communities.
And within that, so as this is scaling up, do you see any need for DNOs or TOs, ESO to change any of their structures and policies? And equally, do you see any sort of government level policy type changes that also need to come through to unlock all this?
So one thing we don't commonly do is we don't commonly offer microgrids onto a retrofit environment. And that's for a couple of reasons. One, because clearly the network's already been established and operated by either a DNO or an independent DNO. And that's a key factor. So you can't then take that on. Potentially you could, but it would be subject to a commercial arrangement. And of course, there's commercial decisions already been taken around that. The other complexity that we have is if in those existing environments, everybody's set up with their own meter, their own supplier. So I think taking microgrids into retrofits hard at the moment. I think regulatory change could be looked at to encourage that. Certainly, it would be in the benefit of communities that want to decarbonize. If you want to introduce renewables, storage, electric vehicles into an existing environment, being able to do that using the principles of microgrid would certainly benefit. But we clearly need to think about how that impacts existing operators and obviously the regulatory side of things. So for me, that's one area of interest going forward. And then...
So if any DNOs want to sell any network...
We'd always really
yes. All right, DNO.
I mean, I think just to put in there very quickly of an example of why this makes a difference. So as an example, I live on a new estate. It's an IDNO adopted estate. It's challenging to get an electric vehicle charging solution in that can be installed and adopted, and it's very painful. 10, 50 meters down the road, there is a charging port that's there that's for the community use and for anyone to use. I can charge my car in my home if I had a charger installed that I could run a cable over a pavement for less than 10 pence a kilowatt hour. if I use that commercial entity one, I'm looking at least 50 or 60 pence per kilowatt hour. The difference with the microgrid system is everything's the same. It doesn't have to have that significant markup in terms of going through. And I think that's the thing that when residents realise that some of these options can end up resolving some of the barriers to entry. At the moment, I won't buy an electric vehicle until I can charge it overnight at home and get the benefit associated from using that cheap electricity, which is then holding back the transition for lots of people who don't have driveways of purchasing electric vehicles and decarbonising. I think the more little things that comes in that smooths the way of going through, that's for the benefit of GB PLC.
And we're doing that exact solution on a site with a developer called St. Martin Homes in Birmingham at Longbridge. And that site is a mid-density new build all-electric site. So it doesn't have driveway parking for all of the homes, but it does have dedicated parking on roadside and in parking bays. And the solution we're doing there is putting dedicated EV chargers on those private parking spaces. And the microgrid allows us to essentially integrate them into the energy bill of the house. So it's no different for the resident, whether they charge on their driveway or they charge in their parking space that's on the street.
I'm very jealous.
One thing that's on our minds is as we scale up the microgrids, we deliver bigger generation plant, bigger batteries and so on, the larger projects. What do you see at Road Knight Taylor as being some of the key challenges that the industry is facing around going down that route?
I think at the moment, it's a very difficult transition with the market at the moment. Networks and markets in particular are particularly full, over 500 gigawatts worth of accepted technologies. And that requires, in the past, the national grid would only be worried about 50 megawatt chunks worth of generation coming on the network at any one specific grid supply point. And that has scaled right back to 1 megawatt. And in some instances, them being interested in 100 kilowatts worth of battery or generation coming on specific networks, especially where there's short circuit current fault level concerns. Lots of new information coming out at the moment as to what should be material, what shouldn't be material, demand also increasing, battery storage limitations, ramped connections, all of these things. A very influx of network rules and systems varying on different grid supply points, different network operators. And I think it's something of being mindful of making sure we're being fair, that people aren't getting a free ride and slipping through and having an unfair advantage, but also not stifling the things that need to happen for decarbonising the UK. And as you get bigger, 949 kilowatts is a magic threshold for most networks. If you go to a network operator and saying, I'm putting on a 2 megawatt battery for my 5,000 home estate, they may look at that and tell you your material and might say you can connect this in 2037, 2038. And there's some things that can be done of working with them to try and get rid of that restriction. But that's one of the things that I think is a challenge at the moment that you might see is how the rules and procedures might well stifle these types of developments. And I think how, as there is reform going on and understanding where should the lines be drawn, taking this into consideration.
Yeah, very interesting. I think that it's really important that if we're going to see these innovations increase and we're going to see the decarbonisation of the built environment, we need to make sure that the energy system operator, the distribution systems, and the various different providers of products and services in the space collaborate, because there's clearly a need to make sure we connect generation and demand efficiently. There's, importantly, harking back to my time at Centrica working on the Cornwall Local Energy Market Programme, I need to make sure that those assets that have flexibility can access the markets right through the segmentation, right through from the DNO, DSO congestion management through to offering services into the balancing mechanism and also helping the ESO manage the transition. So there's lots of complexity in terms of creating a whole system solution. So from our point of view, we're very keen to keep engaging and working towards those solutions.
I think from our perspective, this is really interesting to see because ultimately this is something that started in innovation sites, and innovation projects usually start as being untested, non-commercially viable, lots of barriers in the way. Both myself and Pete have both worked in innovation projects and developed some of these. One thing that we talk about an awful lot is around active network management, another thing that started in the innovation sphere and has become rolled out widespread across distribution transmission markets. It's nice to see another successful story of something that started as an innovative idea of being not commercially ready, not commercially mature, getting to that stage. And obviously still sounds like there's more to be done, but it's nice that it's getting to that stage, and it's another option, area, thing that the UK can do, which is ultimately going to help us to our overall gains, which is decarbonising.
Yeah, and there's clearly always going to be more that we need to do. We need to collaborate to do that. But from my point of view, going back through my journey back to when I started out as a planner, thinking about what is the mechanism we can use to decarbonise homes, which surely these are the easy bits in the decarbonisation agenda. It's really nice now to be talking about working for a company that has a solution and engaging with the wider marketplace to try and drive forward the changes and the evolution that needs to happen and continues to happen. But ultimately, clearly now is a time where these things are happening. We have a solution today that works, and we're already delivering that. We're keen to work with more house builders and more industrial commercial developers and operators to bring that technology to bear. And of course, we're also really keen to work with the system operators to make sure that the way in which we connect EU development, the way in which we operate flexible loads, actually services the system as a whole.
And as you said earlier, it's also really good to see that there's other commercial operations, there's other competitors of yours coming along line, but that's actually for the benefit of everyone. It shows that there is a market and it's been driven that way. And the more people that are doing this in their own way, the better it will be for everyone in terms of the market.
Agreed. And if you want to find out more about Synergy and the products and services we offer, please go to our website, which is www.oursnrg.com.
I think we're out of time. This has been absolutely fantastic to have you on. It's been a real eye-opener for me, learning more about the microgrids. So thank you so much. You've come all the way from Cornwall to see us. It's been great. Philip, thank you for joining us as well. Thank you for listening as well. And we hope you join us for another podcast in the future. Goodbye.
Cheers. Thanks all.
Thank you for taking your precious time to listen to this episode. Now, not everyone is ready to have a connectologist in their life. For others, it's just too expensive. And as our team is so small, we do have to be very selective in what work we take on. And that's why we put so much effort into these shows. We want our society to have the equitable energy system it needs in order to decarbonise and to thrive. So we want to help to topple as many connections barriers as we possibly can, in spite of our size. So please do feel free to ping a link to this episode to anyone you know who might be interested, because it would mean so much to everyone here.